Okay, let's revise waves. I'm going to try and do wave features on one piece of paper. Okay, so we're going to talk about waves, and we need to remember what a wave is. It's a series of disturbances, if you like, but we tend to describe waves as a series of vibrations, or we might use the word oscillations. Same thing, really. Waves are vibrations or oscillations. They transfer energy. Okay, scientists are always interested in energy. That's why waves are such an important topic. Okay, so before we do anything to do with waves, we need to be able to refer to different parts or features of a wave. So we're going to talk about wave features, I guess, is our title. All right, so there's some key terminology that you need to get right. And let's start with a diagram or graph to help get that started. So I'm going to draw a graph. I'm going to label that. I'm going to start off with the dimensions of a wave. Okay, now we're talking about waves being a disturbance. Okay, let's think about a swimming pool. Imagine you've got a nice empty swimming pool, no one's in it yet, the water is looking nice and smooth and flat, and there's going to be zero disturbance. I'm going to have a line of rest when there is zero disturbance of that water. If I jump in and generate waves, okay, then I have a displacement, in this case of water particles. So I can measure, in terms of our swimming pool, how far up and down the water goes. Okay, so it's a measurement of distance. Okay, it might be in centimeters and meters and millimeters, whatever. It's going to be a measurement of distance on the y-axis. On the x-axis, we can think about how far each wave has traveled. We can think about the distance along the wave we're referring to. So that is also a measurement of distance. So in terms of wave dimensions, we can think about how far along the wave we are, and we can think about how far above or below the line of rest we are. All right, so maximum displacement is a thing called amplitude, and I can measure it at a crest or at a peak, and it's called amplitude. Amplitude is a measurement of distance, and it is the maximum displacement of the wave. It has to be measured from the line of rest. That's really, really important. Okay, a common mistake is to measure it from the top of a peak to the bottom of a trough, and that is wrong, because that is two amplitudes, if you like. We've got this bit and we've got that bit, so that is not going to be labelled in your GCSE. You can choose to measure it there or there, okay, one or the other. Now, in terms of how far along a wave we can be, we can think about the length of one wave, and that's going to be measured from like point to like point, similar point to similar point. Okay, so that would be one wave length. The clue is in the name. This is the length of one wave. I can measure it from peak to peak, or I can measure it trough to trough. It's the same length, it'll be the same dimension. Okay, doesn't really matter. As long as you're going from a similar point to similar point, I'm going to use a symbol lambda for wavelength to save me writing. I could measure it at the start of a wave, as long as I finish it at the end then it's okay. That is also one wavelength. Okay. So we've got two measurements. We've got amplitude, that's the up and down measurement measured from the line of rest. And I've also got wavelength. It's another measurement of dimension, but in the other direction. Symbol is lambda, which is a Greek character, and wavelength is, I've spelled it wrong, too many L's. Wavelength is the length of one complete cycle or wave. Okay, so amplitude, let's just highlight that. You need to know that. You need to know that. In terms of time, okay, it's another way we can think of waves. We can think in terms of how long it takes for a wave to pass a point, for example. Okay, I'm going to draw a different graph because this time we're going to have the same label on the y-axis. We're still thinking about displacement, which is a measurement of distance. But on the x-axis this time we can have time. It'll be either in seconds or milliseconds, microseconds. Be careful. All right. But it's important to read the labels on the graph that you're dealing with, okay, so you know what you're talking about. If I draw another wave on here, this time I'm not going to get wavelength when I measure from peak to peak, but I will get the time it takes for one complete wave to pass a point. Okay, so let's have a look. If I measure between here and here, now we're talking about a measurement of time, and that's called period, and it'll be in seconds or milliseconds or microseconds. Okay, it's a measurement of time. So similarly, I can measure a period there. I can also measure from the start here to where the wave ends. That is also period. And we use a letter T for that one, but we're going to use the capital letter T for period. Okay, it's measured in seconds or so. So period, symbol is T, is the time taken for one complete wave to pass a point. Okay, so it's a measurement of time. I can also think in terms of how many waves will pass a point per second. Okay, and that's called frequency. I can't really label that on the graph, but I can define it here. Frequency. We use a small letter F to represent frequency. It is measured in hertz, okay, and it is the number of waves per second, and it is measured in hertz. Capital H, small z for short. All right, we can link these two things together. They're quite similar, okay, which makes them confusing, so be careful. All right, period, capital T, is a measurement of time. Frequency is the number of waves per second. Okay, in terms of equations, frequency can be defined as 1 divided by capital T. We can rearrange that, so we've got capital T, which is period, is the same thing as 1 divided by the frequency. Okay, so be aware of those two equations. They look confusing, but they're not really. Okay, number of waves per second. We could think about that as number of waves per time. Okay, number of waves per second. Okay, that's a bit messy, but I'm sure you can do a better version.